Good viewers, my name is Calvin. I'm taking mathematics for today, and the topic is logarithm. Now, after this class, your lesson objective is number one, you should be able to understand logarithms and the properties associated with it. Number two, you have to express logarithm as indices or in the index form. Number three, you have to express indices as logarithm and vice versa. That is, you have to express indices as logarithm and logarithm as indices. The last objective, you should solve general problems involving logarithm. Right now, you have to get your writing materials and your calculator. I'll be right back. Which stands as the laws of logarithm. Now, firstly, logarithm is another way in which indices are expressed. You can say logarithm is the opposite of indices. Now, since we know that indices is written like this, where we have this thing known as the base, then this b, which is known as the power or index. Now, same thing as logarithm, we have this log, let's say 10 raised to power 5. Now, this log 10 is known as the base, while this 5 is known as the power. That's why I told you that logarithm is another way indices is written. So, we go to the laws of logarithm. Now, law 1 says if you have log 10a multiplied by b, it will be written as log 10a. The multiplication will change to addition, then you have log 10b. So, in a nutshell, what the first law is trying to tell us is that the multiplication will change to the addition sign. Log 2 also, we have, if you have log 10a along b, that will give you log 10a. Your division is going to change to minus log 10b. Now, if you have log 10 a raised to power x, now in this aspect, once you see that your x is not functioning as a power, you can take it backwards to stand as a number. So in this case, we are going to have x log 10 raised to power a. Now another law says that once your base and your power are the same, your base and your power, once both of them are the same, you have it as 1. In the respect of if you have your indices, when anything is raised to power 0, we give you 1. So logarithms are the opposite of indices. Now in this aspect, you see that your base here and your power are the same. It gives us 1. But for your indices, we know that anything raised to power 0 is going to give us what? 1. Then this also looks like that of indices, where your division will change to your subtraction sign, then your multiplication will change to your addition sign, and your division is going to change to your subtraction sign. So with these, let's try and apply it to some examples. So before we move on, let's state the similarities between indices and logarithm.
Hey, are you enjoying this video? Liking this video or leaving your comments will not take anything away from you. It will rather suggest to YouTube algorithm that will make useful educative content and help them rank us better so that we can reach more persons like you. So why not do it? Hit the like button, comment, and make sure you subscribe so that YouTube algorithms can push it upward and make it viral, helping others like you. Thank you.
To express indices to logarithm and vice versa. Now, if I have a situation like this, if I have log x raised to power 5 equals to 32, there is a logarithm question, and I want to express this logarithm in indices form, and at the same time I'm going to change it from indices form to logarithm form. Now, if I want to change this logarithm form to indices form, what I'm trying to do is that I want to eliminate this log from this question. In the case that my answer there won't be log, it is just going to be pure numbers. Now, if I want to eliminate this log, this power, I'll write it out. I have it as 5 equals to. Now, I want to change this logarithm question to an indices question. So, if I want to change it, this power will be written down. Now, this log, if it's moving down to the other side, it is going to become a base. That means if you want to change from logarithm form to indicinal form, your log will be coming to the other side, and when it is coming to the other side, it will be turned to a base. So this I'm going to have, if my log x is coming to this side, I'm just going to have it as x, which is a base. Then this 32 will become a power. Now you see that the logarithm here has been eliminated. I just have pure numbers. I've changed my logarithm form to what? To indicinal form. Now I can also return this question back to this answer back to its original question, meaning that I want to change right now from indices to what? Logarithm. Now, so that brings us to changing indices to logarithm. Now, this is what we have. We have 5 equals to x raised to power 32. Now, if you want to change from indices to logarithm, what you have to do is that this x, this base here, will return back to this position. Now, if it is coming, then you change it to log of the x. So I have this as log x, then this 5, which is a number, a whole number, will turn to what? Will turn to power. This x has been changed to what? Base, but it has what? I've introduced log to it because I'm changing from indices to logarithm. So I have to have log in the answer. So this x coming here will become log x raised to power 5. Then this 32 will become a whole number. So I've changed this indices question, I've changed it back to logarithm. The here I changed it from logarithm to what? Indices. So let's pick some examples to buttress the points earlier stated. Now these are examples to buttress changing from logarithm to index form. So this is the first example. Let's check it. I have log x to this power 16 equals to x. Now, if I change it from logarithm to indices form, you have to eliminate this log. That is, this log should be eliminated. It should not be found in the question. And I told you that this power, which is 16, will be written as a number on its own. After you have done that, now this log 2 will be moving to the other side. Now, if it is moving to the other side, it's just going to become 2. That's the base. Now the log has been eliminated. So it will become a base which is going to have x as its power or index. So these you have changed from logarithm to what? Index form, and from here you can solve for x. Now, I told you in the previous class that if you are solving indices question, the base will be similar. There will be similarities between the base given to you. Now, 16 and 2, there are similarities between them. Indicates that 16 can be changed to base of 2 and is going to have a power. Meaning that you can convert 16 to base of 2. We are going to have 2 raised to power what? 4. Meaning that 2 times 2 times 2 times 2. 2 in 4 places is going to give us 16. Then I have 2 raised to power what? X. Now the bases are the same, so you eliminate them. You cancel it out. So our final answer for x equals to what? 4. This is if you are asked to solve further. But if you are just asked to change the logarithm form to an index form, this is where you're going to stop. But if you are asked to simplify or to solve for x, your answer will be x raised to power 4.
Hi, do you know that you can get better in-depth teaching on this topic you are watching right now? Simply use the link in the description where you can get access to our tutors, your favorite tutor one-on-one, and discuss a conversation on joining our live class. You can also go to our website on www.allcbts.com to book a session with your favorite tutor.
For the second example, we have log base 1 over 3x equals to minus 2. This should be easy to solve. Now, your x is going to stand on its own. Then your log 1 over 3 will become to the other side. So you have it as what? 1 over 3. Then it will be raised to power minus 2. So this is the solution to the 2 questions given to you, changing logarithm form to an index form. So this is where you're going to stop. But if you are right now, you can continue further even to get your final answer for x using the law of indices we learned in the other class. Now, I told you that if you have your power as negative, that will be x will be 1 all on the number itself. That will be 1 over 3, everything raised to power 2, which is 1 all on 1 square is 1, all on 3 square is what? 9. So this you can write it as 1 divided by 1 over 9. With the idea of BODMAS in fraction, our division is going to change to multiplication. So we have 1 times 9 over 1. Our final answer will be 9. Now, these are some logarithm questions. First one says, solve for x if log base 10, 8x plus 1 minus log 10, 2x plus 1, everything is equals to log 10x plus 2. You have to look for x in this question. Now question 2 says that given that log 2 equals to 0.3010, if you press this on your calculator, to surely give you this figure. And log 10.5 equals to 0.6990. Evaluate correct to third significant figure, log 15 minus log 40. Then question 3 says simplify log a raised to power 3 minus a all on log a. So I'm going to provide solutions to these questions. Now, solution to this. Now you have log 10 beta x plus 1 minus log 10 2x plus 1 equals to log 10 x plus 2. Now the first thing you have to take notice of is the base. You can see that they are all expressed in the same base. Log 10, log 10, log 10. Now, in the laws of indices, we learned before, if we have the same base, we have to pick one of it. So here we have it as log 10. We have here 8x plus 1. As we know that our minus is going to change back to what? Division. So we know that division will result to subtraction. Then also subtraction can be changed back to what? Division. Then I have 2x plus 1 equals to log 10 x plus 2. Now I can write this in this form. Log 10 8x plus 1 ln 2x plus 1 equals to log 10 x plus 2. Now since the base are the same, cancel it out. This will cancel this. So I'm left with 8x plus 1 ln 2x plus 1 equals to x plus 2. And can have on 1. So what's the next step we do? What? First multiply. Meaning that this is going to multiply this, this is going to multiply this. So we are going to have it as 8x plus 1 multiplied by 1 equals to 2x plus 1 multiplied by x plus 2. So we can expand the bracket. 1 is going to multiply all what is inside here. Then x plus 2 is going to multiply or open this bracket. So let's multiply each time. 1 times 8x, here I have 8x plus 1 equals to 2x times x, I have it as 2x squared. 2x times positive 2, I have it as 4x. 1x, 1 multiplied by positive x, I have positive x. Then positive 1 multiplied by positive 2, I have it as positive 2. So from here, let's simplify our expression. Here I have 8x plus 1 equals to 2x squared plus 4x plus 4x plus x will give us 5x. So we have here 5x plus 2. So what next is we have to what? Collect like times. Collecting like times. So we have to collect x points at one place, 5x, 8x, those times that are similar, we have to collect them together. So here I have 2x squared, I have plus 5x, I have 8x here, 8x should move to this point. So if 8x is coming here, it will become what? If positive is crossing this bridge, it will become negative. So if 8x is coming to this side, it's called minus 8x. I have positive 2 here. Then if 1 is coming to this side, it's going to become minus 1. Now I've collected like times. So what did I have as my answer? I have here 2x squared. I'm having 5 naira, I'm only 8 naira. I'm left with minus 3x. And yeah, I'm left with 1. I can say everything is equated to what? To 0. Once you got to this point, then you are left to make use of your 3 formulas. Is it that you choose out of it? Is that you use completing the square method, factorization method, or you use your quadratic formula? So right now, we're making use of the quadratic formula, which says,
hello, if you're enjoying this video and want to see more content relating to this towards your examination success, make sure you like this video, make sure you subscribe to this channel, share it with your friends, okay? Because we'll be releasing loads and loads of beautiful content tailored towards your examination success in one sit. Now let's get back to the class.
Applying the quadratic formula, which states minus b plus or minus square root of b squared minus 4ac on 2a. So once you state the quadratic formula, then you have to equate it with these equations you have. Now the equation given to you is 2x squared minus 3x plus 1 equals to 0. Now in the formula we have just letters. We have b, we have b squared, we have a, we have c. Now how is it in relation to this? because this is an quadratic equation. That's the reason why I'm using the quadratic formula. You can also use the factorization method or completing the square method, but I prefer to use the quadratic formula. So your A is your first term. That means the number in front of your x squared will always be your A. Here we have it as 2. Your B is the number in front of your x. Here we have it as -3. Then your C is the constant. That means the third number given to you, you have it as +1. So once you have gotten your A, your B, and your C, you can integrate it into this formula. So let's do that, so that we can get our values for what? For x. So here I have minus, then my B, I have it as what? -3. And don't forget I have plus or minus square root of my B is still the same as what? -3 squared minus 4 multiplied by my A, which is 2, multiplied by my C, which is +1. Everything is over 2 multiplied by 2. So let's have it. Minus times minus will give me +3, plus or minus square root of -3 square means -3 times -3, -3 times -3. So that will give me what? 9. Once you put that in your calculator, I have minus 4 times 2 will give me 8. 8 multiplied by +1 is going to give me 8. All on 2 times 2 will give me what? 4. So here I'm going to have it as +3. Oh, sorry for that. I'm going to have it as +3 plus or minus square root of 9 minus 8 is going to give me 1, and we know that the square root of 1 is 1. All on what? 4. So here I'm going to have it as +3 plus or minus 1 all on 4. Now once you get to this junction, the reason why you're having plus or minus is for you to be able to split this fraction. You're going to have the positive side, I'm going to have the negative side. So to get the positive side, I have here, so my x I'm looking for will be +3, I'm picking the positive, +1 all on 4, or +3, I'm done with the positive, I'm picking the negative, -1 all on 4. So like I said, our final answer, +3 plus 1 will give me 4/4, or +3 minus 1 is going to give me 2 all on 4. So my x will be 4 divided by 4 is going to give me 1, or 2 here 1, 2 here 4, 2 here 2. So therefore, the values for x in this equation is x equals to 1 or half. So we have come to the end of this solution. So the values for x in this question is x equals to 1 or half. Now question 2 says, given that log base 10 raised to the power 2 equals to 0.3010, and I told you earlier on, if you should twice this on your calculator, is surely going to give you this figure. And log base 10 raised to the power 5 equals to 0.6990. Evaluate to 3 significant figure. Log base 10 50 minus log base 10 40. So this type of logarithm question, we call it substitution, meaning that you're going to substitute these two values into this question given to you. So
Hi, chat with us to join our live classes that hold special for JAMB, IELT, WAEC, NCE, Beckett, and the likes. Okay, you can use the number on the screen right now.
all what we are going to be making use of will be log 2 and log 5. Now, how can we bring these two values into this question? Now, firstly, let's express the question with log 10, 50. What are the numbers that can give us when we multiply them together? That is going to give us 50. Now we have 25 times 2 can give us 50. We have but let's make use of 5 times 10. 5 times 10 is going to give us 50, and minus log 10, what will give us 40. We have what? 4 times 10. Now, using the law of logarithm, which says that multiplication will turn to addition. So here I have it as log 5 plus log 10 minus, here I have log 4 plus log 10. Now you see that this equation looks exactly like this. Now these two values has been integrated into this equation. Now here I have my log 5, here I have my log 4, but it is not well balanced. Now here I have my log 5 plus laws of logarithm, which says if your base and your power is the same, you have it as what? 1 minus log 10. 4 can be changed to base of 2, which we have 2 raised to power 2 plus log base 10 raised to power 10. You give me 1. So here I have it as log 5 plus 1 minus, now this 2 is not functioning as a power, so I will turn it back. So I have it as 2 log 10 2 plus what? Plus 1. So you can see that this 2 has been substituted into this value. So here I have my log 5 plus 1 minus, I have my log 2. But actually it was log 4. It was broken down to 2 raised to power 2. And I told you that if your power is not working as a power, you can return it backward, which is, so you are going to have it as 2 log 10 2, which is exactly what is given to us here, then plus 1. So if you wish, you can collect like tens, or I can say, since I also have it as log 5 minus 2 multiplied by log, now this is what this means, 2 multiplied by this plus 1, but actually since this minus is going to affect this minus this, so that means minus times plus is going to, we are going to have it as minus what? 1, then this positive 1, I put it here. So this is going to cancel this. So what is my log 5? My log 5 is what? 0.6990 minus 2 multiplied by, what is my log 2? 0.3010. So 2 is going to open this bracket, so I have 0.6990 minus 2 times 0, 0, 2 times 1, 2, 2 times 0, 0, 2 times 3, 6, 2 times 0, 0. So subtracting this, you have 0.6990 minus 0.6020. Subtracting, you have 0. 9 minus 2, you have 7. 9 minus 0, you have 0. 9, sorry. 6 minus 6, you have 0. So our final for this question is 0.0970. So this is the solution to the question above. Now, this is an exponential equation in logarithm. The question says find the value of x in the following: 2 raised to the power x equals to 5.7. Then example 2 says that 8 raised to the power is equals to 3.5. You'll be wondering that which kind of question is this? It's a very simple question. It's just that it is your manner of approach that determines. So solution. Now you have.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit the notification button.
2 raised to the power x equals to 5.7. Now the first thing you have to do is you have to take the logarithm of both sides, taking the log of both sides. So if you want to do that, then you have it as x is going to come down log 10 to, then we have it as log 10 5.7. Now you have to take log of both sides in this question. So x is going to come down, then you have log 10 to, because your logarithm is always expressed as what? Base 10, except if you are giving other base. But normally on your calculator, your logarithm is always expressed in base 10. So we are looking for x. Once you have taken log of both sides, you see that you're almost done with the question given to you. So what is disturbing x here? Log 2. So you divide both sides by log 2. So x equals to log 10 5.7 over log 2. So x, press it out in your calculator, log 5.7, you have it as 0.7559 on log 2. Once you press that in the calculator, you have it as 0.3010. So dividing both sides, 0.7559 divided by 0.3010. Then your x is 2.5113. You have gotten the value of the x. So it's still the same process I'm going to use for this. You have 8 raised to the power x equals to 35. Now taking log of both sides. So you have this as x log 10 8 equals to log 10 35. So you are looking for x, divide both sides by log 10 8 log 10 8. So x equals to log 35, just press the calculator, the x divided by log 8. You're going to have the answer as 1.7097. So see, it is as easy as ever, just taking the log of both sides and dividing by what is disturbing your x. You have gotten your x.